Okay, here we are, starting trig, the holy grail of mathematics. First of all, I want to remind you that tonight the co-rec is all about trig. In fact, the next three, this one and the next two, will be about trig and inverse trig functions. And so we'll really get into the nuts and bolts of what you should have learned in Math 100 or in your previous math classes with respect to trig. And in particular, we're going to really focus on what you need for success in calculus and in classes like circuits and Calc 2 and physics, where you have to do some trig, a lot of trig, and some differentiation with trig. So here we go. I'm going to write down a few facts here that I need. And they're facts I'm going to use in the proofs of two derivatives. And later on, if I have to, I'll prove them. We'll just take these as facts. So one of them is two of them are from the past. So if you have the sine of x plus h, this is equal to sine x cosine h plus cosine x sine h. All right, that was one of those trig identities. There's also two limits that we use without proof, and that is if you take the limit as h approaches 0 of cosine of h minus 1 over h, you get 0. And also if you take the limit as h approaches 0 of sine h over h, you get 1. These are a pain to show without the L'Hopital's rule. So for now, we'll just state it as fact, use them, and then later on in the course, when we have L'Hopital's rule, I'll prove why these are true. Okay, so let's jump into this. And I'll come back to these facts that I need later on. Okay, so, well, we're going to let f of x equal the sine of x. And there's always supposed to be parentheses around the argument. So up here, there should be. But once you do a lot of this, you really just drop it. It's implied that, well, it's true that x is the argument. So you're taking the sine of x. Okay. And just for a quick review of the triangle here, a right triangle, if my angle is x here, this is the side opposite, side adjacent, side hypotenuse, and so what is sine? Sine is, it's the ratio of the opposite side over the hypotenuse. We look at it more as a function. And what we want to do is we want to find the derivative of sine x. Okay. So this is the limit as h approaches 0 of sine of x plus h minus sine of x over h. Okay. And now this is the limit as h approaches 0, and sine of x plus h is up here, right? I use this trig identity. So it's sine x cosine h plus cosine x sine h minus sine x all over h. Okay. I'm going to collect the signs. So I have sine x cosine h minus sine x plus cosine x sine h all over h. Okay, we're going to break this up into two limits. Right, and that comes from this guy. I factor the sine out. And then over here I have the limit as h approaches 0 of cosine x sine h over h. Okay. Now note that since sine x and cosine x in both of those limits don't have any h's in them, we can pull them out front. So I have sine x here, cosine x here, times the limit as h approaches 0 of cosine h minus 1 over h, plus the cosine x times the limit as h approaches 0 of sine h over h. Okay. All right, and from up above, that equals 0, right? And from up above, that equals 1. And so we have 0 plus cosine x, which is cosine x. All right, so the derivative of sine x is cosine x. Sweet. Okay. Now let's find the derivative of cosine. So just writing out all this stuff, this is cosine x plus h minus cosine x over h. This looks very, very similar to the last proof. It's a little tweak. Cosine x plus h has this identity: cosine x cosine h minus sine x sine h minus cosine x all over h. And just like before, we're going to collect the cosine terms. So I have cosine x cosine h minus cosine x minus sine x sine h all over h. Okay. Separate and divide up the limits. Like that. And what? From above, that equals 0. And from above, that equals 1. And this negative is very important here, because now the derivative of cosine is minus sine. In a perfect world, it would be the derivative of sine is cosine and the derivative of cosine is sine, but it's not quite. The derivative of sine is cosine, derivative of cosine is minus sine. Now, because I like to think of math as a war sport, I really want to give you the best tools possible. As long as you know that the derivative of sine is cosine and the derivative of cosine is minus sine, you can find the derivative of any other trig function. There's no memorization here. If you know the rules, so for example, what's the derivative of tan x? Okay. Well, remember, tan x is sine x over cosine x. So this is going to be the derivative of sine x over cosine x. Now we use the quotient rule. Right? And that's low d high minus high d low over low squared. And distributing the negative, we have cosine squared x plus sine squared x over cosine squared x. That identity on top is very popular and famous, and we'll talk about it tonight. That's 1, and that's 1 over cosine squared x, and 1 over cosine is secant. Right. So that's how you find the derivative. So if you wanted to find the derivative of cosecant or cotangent, or secant, you just use the quotient or the product rule and it'll give it to you every time. All right, much to do in class today. I'll see you in a minute.